Okay, this video is on your classifying equations homework assignment. We're going to go through a few of these problems together. And in order to do this, you need to be able to identify the types of reactions for all of these given either the products or the reactants. And then you will need to use the general equations for all of these reaction types in order to figure out what type of reaction it is and to complete the equation, and then we'll need to balance it at the end. So you'll need to have either this, if you probably don't have this memorized at this point, so some type of overview of the reaction types in your notes would be helpful. And then also we are going to need the solubility table and your periodic table for phases of elements if you do not know those off the top of your head. So the 5 reaction types that we'll be using are synthesis, decomposition, single replacement, double replacement, and combustion. So all of these will fall into one of those categories, and we can also assume that all of these reactions will be taking place. Right now we are not predicting yet. So all of them will happen, we just need to figure out what type of reaction they are and complete it. But we have to have phases, which is why we need our solubility table. Okay, so the first reaction, when we look at it, we should recognize that first of all there are 2 reactants and both of them are compounds, right? This is a compound, this is a compound. So when we try to figure out what type of reaction this is, we need to look at, on the left side of the arrow, which type of reaction starts with 2 compounds. Okay, well this is an element and an element, this is one compound, this is an element and a compound. Here we have a compound and a compound. So this is looking like a double replacement reaction. So in a double replacement reaction, we start with these 2 compounds, and then remember the positive ions are going to switch partners. So when we do that, first of all, we can identify this as double replacement, and you can just write DR for double replacement. Make sure I'm in focus here. And we need to think about the charges when these switch places. So if it's helpful for you, you can write the charges above or below just to keep in mind what the charges are here. So for example, calcium I know is a 2+, bromine's a 1-, or bromide's a 1-, silver's a plus, nitrate's a -. So what's going to happen, you can think of it as the positive ions switching places, or you could think of it as the negative ions switching places, either way. But when they switch places, now calcium is going to be with the nitrate, and silver is going to be with the bromide. So when we write our products, you can choose the order of the products does not matter. It's just that the formula has to be correct. So I will write silver and bromide first. And in order to write the correct formula, you need to balance the charges. So silver is a +1, bromide's a -1. So that formula is easy. It will just be AgBr. Okay. To get the phase of that, we need to use our solubility table. Silver is down here, bromide up here. It tells us it's I, which means insoluble, so it's a solid. So here we'll write solid. And then we have to write the other product, which is now the combination of calcium and nitrate. So calcium has a 2+, nitrate has a 1-. So that means I need 2 nitrates in the formula for calcium nitrate. So I'll write Ca, parentheses, we need 2 of those, right? And then we need to get the phase of that. So calcium's here, nitrate's here, S, which means soluble, so it's aqueous. Okay, so that's that part. And then we do have to balance at the end. So use your balancing skills. Calcium, and we can chunk the polyatomic ions. Remember, count that as one thing. So calciums, we have 1 on this side, 1 on this side. Bromides, we have 1 on this side, or 2 on this side, 1 on this side, which means we need a 2 here. By putting that 2, we're now changing our silvers. So we need a 2 on this side, which changes the nitrates, right? NO3, NO3. So you have 2 nitrates on this side, but this side, because of the formula, we also have 2 nitrates. So that works out. So that one is done. So that's a double replacement. All right, let's try the next one, number 2. So number 2, we have an element and a compound. So in order to figure out the products, go to our cheat sheet, figure out which one starts with an element and a compound. Not that one. Not that one. This one looks good. Element, compound. So let's see what happens. In a single replacement, remember this is the sad date where your friend swoops in. So these guys are going to switch places depending on the charge of this. If this is a positive charge, it will switch with the positive. If this, when it becomes an ion, is a negative ion, it will switch places with the negative ion. So let's see what we have here. So here we have aluminum as the element. So when aluminum becomes an ion, what charge does it have? Aluminum is a metal. All metals take on a positive charge. So that tells us that when it comes in here and kicks out someone, it's going to kick out the copper, because copper in the compound is the positive one. Okay. So what's going to happen? Aluminum and copper are going to switch places. And again, when we get our products, we have to take into account the charges. So aluminum, 3+. This copper, remember copper could have 1+ or 2+, but since there are 2 chlorides, we know it's a 2+, and chlorides -1. Okay, so aluminum's going to go in and kick out copper, which means that copper now becomes just the element copper. So its formula is just Cu. Remember, there's no charge on elements. It did have a charge in here because it was in a compound, but now that it's on its own, just an element, it's neutral. So whenever you're doing these reactions, all of these equations, nothing should have a charge on it. Sometimes we'll write them above just as a tool for us when we're balancing the charges on the formulas on the other side, but you should not have any charges on any of these. Okay, so we have copper, which to get the phase, you can use your periodic table if you don't know that copper is a solid. And then the other, now we have an element, we need a compound. The compound is going to be the combination of aluminum and chloride. So aluminum has a 3+, chloride has a -1, which means we need 3 of those. So AlCl3. Phase, we have to use this. It will be, for a single replacement, the compound will be aqueous, but we will check aluminum, chloride, S, soluble, aqueous. Okay, and then yes, we have to balance. So this one, balancing, Al here, 1 and 1, good. Copper, Cu, Cu, good. Chlorine here is the tricky one. We have 2 on this side, 3 on this side. So this happens a lot at 2, 3, which the easiest way to fix that is to make them both 6. So in order to make this 6, we need a 3 here, which changes our copper, right? So that means we need a 3 here. To make this 6, we need a 2 here. So 2 times 3 is 6, but that also changes our aluminums, so we need a 2 here. Okay, so now that one's done. Alright, let's look at, actually we can just do number 3, the next one. Number 3 looks a little different. Number 3 does not give us reactants, it gives us a product. And it's just one product, and that product is a compound. So let's look at our list. Which one of these gives us one product and the product is a compound. Well, actually, only one of them gives us only one product. It's synthesis. So remember, that's where elements combine to make a compound. So this one's just a little bit tricky in that, yes, we have one compound, but in order to figure out the elements that made it, this one actually has 3 different elements. So all you have to do is break apart all 3 of those as your reactants. So we have potassium, and we need the phase, so if you can use your periodic table, do that. Otherwise, maybe you know, potassium is a solid metal. It is soft, but it is a solid metal. And then we have carbon is also in there, which is also a solid. I didn't really leave much room for balancing. You do need to balance this after. And then oxygen, do not make the mistake here. Oxygen, we need the element oxygen. What is the formula for oxygen? It is not O. Oxygen is special. It is one of the super 7. Brinkelhoff, it is diatomic. So the formula is O2. And it is a gas. So those phases are from the periodic table because these are just elements. So we don't need our solubility table. But we do need the balance. Okay, so potassium, 2 on this side, which means we need 2 on this side. Carbon, carbon, good. Oxygen, 3. Oxygen, 2. So again, one of those 3 2s. So to fix that, make them both 6. So to this, I need a 3. 3 times 2 is 6. Here, I need a 2. So we have 2 times 3 is 6 for the O's. But now, look, I'm changing now the potassiums and the carbons. So because of that, this is no longer a 2. This has to be a 4. So if you have pencil, erase that. I hate using pens. And then 2 also affects the carbons. So you need 2 carbons. So that 2, 3 is very common in balancing. So that's kind of a helpful trick to make those 6. Usually works out nicely. Okay, let's see. What other one would be a good one? Let's do the very last one on the front page here. Or not this one, number 8. Do number 8. It's a little different. Number 8, we have this compound, C3H6 plus O2 gives us what? Oh, and I forgot, actually on both of these, we never wrote down, this we said is single, and this we said is synthesis. Alright, you do need to put that on your homework. Alright, down here though, C3H6 plus O2. So if we look at our cheat sheet here, it's a compound and an element, kind of, but this one's very special. Notice it matches up with this last one, the combustion one. So in the combustion one, what this means is this is any compound that's made up of carbon and hydrogen, and maybe it has oxygen, but it doesn't have to have oxygen. So it has some number of carbons, some number of hydrogens, and it's reacting with oxygen. If that is the case, like we have here, it is combustion. And the products are very easy, because the products will always be CO2 and H2O for this reacting with this. Something with carbon, hydrogen, maybe oxygen plus O2 will always give you CO2 and H2O. So that's all we have to do for this. CO2, just a gas, and H2O, which at this temperature, we know combustion, that's when it's like an explosion, will also be a gas because it's really hot. So then we just need to balance this, which this one we'll go through, and we don't want to start with oxygen because that's in a bunch of things. So start with carbons. So carbons, we have 3 on this side, we have 1, so we can put, here's my blue, put a 3 here. All right, and then again, hold off on oxygen, do the hydrogens next. 6 on this side, 2 on this side, so we can put a 3. Now we'll try to balance the oxygens. So we have 3 times 2 is 6, plus 3 times 1 is 3, so we have 9 total on this side. Well, that's a problem because this side's always going to be multiplied by 2, so we can't get an odd number. So if you look back in your hints for balancing, the trick for this is to double all of the coefficients that we've used so far if we get stuck on a diatomic element. So this invisible 1 becomes a 2. Wait on this. This 3 becomes a 6. This 3 becomes a 6. Now we can try to balance our oxygens. So 6 times 2 is 12 here, plus 6 is 18. So now we have 18 on this side, which means to make this 18, we can put a 9 here. So again, if you have pencil, you can just erase the numbers you had. We'll go back and double those. Okay. So it's pretty common to happen on combustion reactions, where you have to double the coefficients. Okay, so that's a few from that. Let's do one more. A little bit more work on the second half of these, where they just give you the words. Actually, in this one, it gives you the formula, but I'm going to do this one anyway. So gaseous ammonia, but sometimes it won't even give you that. Hopefully by now you know ammonia anyway is NH3. Okay, and it says it's a gas. So that's the information given. So we have a compound. That's it. As a reactive. Let's come over here. Look at our types of reactions. Which one starts with just a single compound? This one, decomposition. Okay, so decomposition means that a compound is breaking down into its elements, right? So for this one, we'll take ammonia, and we need to break this down into its elements, which it is made of nitrogen and hydrogen. But again, don't make silly mistakes here. Nitrogen and hydrogen are both special because they are diatomic. They are also both gases. Okay, so those phases you can get from the periodic table if you don't know that those are gases. Then, when this is, we said decomposition, then we can balance. Nitrogens, 1 and 2, so in order to make this 2, put a 2 there. Now our hydrogens are changed, 2 times 3 is 6, so we need this to be 6, put a 3 there. Okay, so that one's was meant to be a little bit harder because it gives you the words, but this one actually did give you the formula. But some of these, you just have the words, so you need to first make these into formulas, and then figure out the reaction type, then figure out the products or reactants, and then balance it. Okay, so this is your classifying equations assignment. If you need a cheat sheet like this, might be helpful for you, or for your test, put this on your note card. This will be helpful for your assignment, as will your solubility table. This will be given on a test, as will the activity series. Okay, so this comes first, and then you can work on your predicting products assignment, which will be very similar, but you will actually have to check using your solubility table in your activity series if the reactions actually happen. So all of these will happen on the predicting products assignment. You may get some that are no reaction. Okay, so good luck.